How do we get started here? So f of a plus 3 minus f of a. And all right, there's basically two problems in one. What's f of a plus 3 mean? Wherever there's an x, what do we plug in? Equals 3. You get two x's. I'm gonna put it in brackets just to kind of separate them. So it's 3 times a plus 3 quantity squared minus 2 times quantity a plus 3 plus 5. Okay, that is f of a plus 3 minus f of a. Well, what's f of a? You just take out the x and plug in a, but you got to make sure that the second one's in parentheses. All right, see what you come up with. For that, I'm going to hand out your guided notes for today, and then I'll collect the homework here in a little bit. If you're writing on the back of it, I'll wait. But let me hand out the guided notes. Let's see what you come up with.
Sorry for all the rabbits around my homework. It sheds bad. Is that on the video? Just me talking about rabbits.
It is.
Say it a little louder. Yeah, for the people in the back.
Okay, who were there? All right, let's get a 2W.
I don't know. I'm sorry. It's a subtraction. I get subtraction. Yeah. I still got negative 3. I'm Am I wrong? Oh.
That's wrong. Stop right there.
Is this right?
You're close.
You're joking. Okay.
Thanks for trying. You guys are all close.
He said thanks for trying. Yeah. This isn't okay for trying. Okay, I solved it, but I think I know what I'm doing. Did I need to distribute the negative? I think that's the deal. I did distribute the negative. I didn't.
Oil first, then distribute.
Oh, I didn't distribute.
Okay, I didn't distribute.
You just put it.
I don't know why I put it.
I saw.
You're close.
How is this close to find this many numbers? That's too late.
Minus or negative.
But I don't. Because you're trying to do steps, right?
Oh, yeah.
Oh,
Yeah, right here. This 2A.
27.
Somehow worked into a 4A. All right. Jackson, you got the answer? No? You don't even want to try?
I got 14A plus 30. I don't know.
Oh, you're really close. I know the mistake you made, but you're really close. It's not correct. It's 18A plus 21.
20 what?
21. 18A plus 21. Now let's take a quick look.
That's a really good one.
I had nothing close to that.
Oh, wait, that is what I got.
All right, let's go through here. The biggest mistake in Jackson and is you don't distribute that negative. I don't think you distributed your negative. So that may or may not be. I think it is, but we'll see. All right, FOIL. Okay, right here. And when you FOIL, you get a squared plus 6a plus 9. Distribute your negative 2. Negative 2a minus 6 plus 5. And here's what I would tell you to do. Right here, you have minus this f of a, whatever f of a is, but you have to treat it as if it's in parentheses like we have it written, but then that becomes minus 3a squared minus a negative 2a is plus 2a minus positive 5 becomes minus 5. So all those signs are going to flip, not just the first term, but the negative 2a will become positive, positive 5 will become negative. So be careful there. Distribute the 3a squared. Whoops. Plus 18a plus 27 minus 2a minus 6 plus 5 minus 3a squared plus 2a minus 5. Now it's just combining like terms. Now it just says, I don't know, what does it say? Calculate? It doesn't say solve. Like don't throw in an equal sign. Don't get a equals. Just simplify, combine like terms. We got 3a squared minus 3a squared, 0. 18a minus 2a is 16 plus 2a, 18a. 27 minus 6 is 21, plus 5 is 26, minus 5 is back to 21. So that's how we get 18a plus 21. Okay. All right, I'll collect that homework here in 1 second. Make sure you have a name on it. I'm not going to grade number 12. That was just a little challenge problem for you. If you got it, great. I want to get you started on the notes while I collect it. Today is a busy day. It's going to take me most, if not all, the period. I apologize now, but we got to move to get through all this. There's a ton of stuff in 2.5. We got increasing, decreasing functions, relative max, relative min, even and odd functions, which probably is what you're least familiar with. And I find the most mistakes. And then the average rate of change, you tend to be pretty good with that. All right, on your notes, go ahead and there's that first graph. Copy this down. And then there's the key piece you need to put in there. Okay, then I'll collect your homework. Oh, zero.
Yeah, it's just showing when And it's just, and it's between the section A and B, why like a parentheses. You kind of just, whenever you put a 6 instead of the B.
It's yeah. It's a 3 mile record.
They say that.
Alright, increasing function. This is something that you know what it is, you've seen it, but to mathematically describe it, you gotta go into, I guess, a little more detail. So, and hopefully this makes sense, if x1 is smaller than x2, when you substitute them in, if to be increasing, it has to be going up. So this means f of x1 would have to be smaller than or less than f of x2. Okay, so that would be that line at the top. All right, now this is increasing, decreasing, very similar. You got a function going down from left to right. Whoops. All right, this is not acting up. We'll just get rid of that. Okay. Going down from left to right, decreasing, downhill. And for that case, when your x1 is on the left, its value when you plug it into f has to be greater than the value of f of x2. So that should go in that top, or in that line at the top above there. Now, if I happen to go too fast, slow me down. But this is a little bit longer lesson. Come on, Cassie. No time for mistake.
Oh, shoot, this.
Watch it forever. All year, watch it, listen to it.
Yeah, all 4 of your subscribers. I did subscribe to you.
You did?
Yeah, I subscribe to all the math teachers.
Maybe I should subscribe to them. All right, last one, constant function. Horizontal line means all the y values are the same. Okay, you got a constant. If x1 is less than x2, it doesn't, any 2 points, then f of x1 is still will equal f of x2. All right, we've talked about increasing, we talked about decreasing, and then we talk about constant. We also want to identify intervals that functions are increasing, decreasing, or constant over. So you see that picture right below there. Just a generic graph. All right, where is it increasing? Where is it decreasing? Where is it constant? Now make sure you don't read this going from right to left. We always read it going from left to right, from smaller to bigger. So this is really increasing, okay? Even though that arrow is going down, if we go left to right, it would be increasing. It would be increasing on the interval from negative infinity to, what is that x coordinate? -3? All right, for the increasing, decreasing, and constant, there will be no brackets, okay? It doesn't include the point. It just goes to the point, because at that point, it changes. Okay, it changes to a constant. Now, the next line says decreasing. It will be decreasing from 4 to infinity. And then it will be constant from -3 to 4. So that's basically increasing, obviously increasing rises from left to right, constant stays the same, decreasing goes down from left to right. For this, just be able to identify those intervals. All right, relative max, relative min. Okay, those are peaks and those are valleys for those. As you take a look at that below there, okay, points whose y-coordinates are relative max. These two right here, it's the highest point in that area. You got to watch saying the word absolute, because if the graph continues, like if this continues up, we couldn't say that's an absolute max, okay, or that's an absolute min. Okay, so just say relative. So you can have more than one relative min for a function. You can have more than one relative max for a function. On that grid to the right, if you would, just sketch this right here. All right, we're going to identify relative min, relative max, and then increasing and decreasing. So what we would say, this has a relative max of 3.5 at x equals -3. Okay. So relative max of 3.5 at x equals -3. Sometimes you'll just say the relative max is x equals -3. Relative min of -1.4 at x equals, what is that? 1.7. All right, take a look, see if you can identify increasing and decreasing. We'll list those here in a second. But where is the function increasing? Where is it decreasing? For that. Thomas, Cassie, what do you think on increasing?
Negative infinity to -3.
Okay.
And 1.7 to infinity.
1.7. Yep, you're going to use the x coordinates. Just for union, if you get two different intervals, union in between there. So that's where it's increasing from left to right. Goes up to that point, and then from 1.7. So Nathan Popio, where's it decreasing on?
-3 to 1.7.
Good. -3 to 1.7. All right, now we talked relative max, relative mins. We can also have some different terms for them, as you see below there. We can also call it an extreme value. Okay, basically extreme value is either relative max or relative min. And then another label is a turning point. Okay, it's going to change from increasing to decreasing or decreasing to increasing. Okay, so you get your turning points, you get your extreme values for them. All right, yep, flip it over. All right, we're going to graph this one on your calculator. Now the function is, it says calculate the relative max and relative min for f of x equals 99 times out of 100. You're not going to be able to look at the function and tell me the relative max or min by looking at it. Okay, you're going to have some form of graph. Go ahead and graph it. Does it have a relative max and a relative min from your? Right. Okay, it does. All right. Okay, find the coordinates. How do I find the coordinates of the relative max? The relative min is 0, 0. But from this right here, you got negative x to the third power plus 3x squared. All right, how do I find that? Do you remember how to find that relative max? Okay, Connor?
Go to calculate and then second calc.
Okay.
And max.
All right, good. Exactly what he said. That's what I wanted you to say. At the top, you got your 5 buttons at the top. It says trace, it says calculate. If you go to second trace or second calculate, you get this menu. It says value, 0, minimum, maximum. We want to know the maximum for this case. So you go down to number 4, or you hit number 4, and you hit maximum. It will say left bound. It says, I need a point to the left of this maximum we're looking for. Okay, so you just need to be somewhere to the left of it. Somewhere somewhat close. Don't be way, way, way to the left. Okay, so you're going to hit that. And now it says right bound. You have to make sure you go past the maximum and you're to the right of it. The 2 arrows should be facing each other. All right, see what you get. Hit enter. Okay, see what you get. Yeah, so what does your x value say?
I got 2.0000018362.
2.0000. We'll throw in another 0. 18. Right around there?
Yeah.
All right. So you got that. Nathan, what'd you get?
I get for my X,
Yeah.
I got 2.7659.
Oh, wait a minute. 2.76. Did you hit enter? Hit enter.
No.
Hit enter.
I got 1.999999998.
8.
Yeah.
All right. You probably got different answers. Okay, you probably got different answers. So if I hit enter here, okay, I got 2 and I got 1, 2, 3, 5 zeros and a 1. I'd be smarter than your calculator. Is actually what? Actually 2. Don't ever put down 1.999999998 as your answer for this one. Okay, it's because your calculator has an algorithm it goes through and there's a round off there. And this is what happened. So it's going through this process. It has a little bit of an error. So it thinks it's 2.00001 or 1.999. Answer's 2. Okay, just make sure you understand that when you use your calculator. That can happen at times. All right, so relative max of, and what is the y coordinate there? It's 4, right? I don't think anybody has an issue there. At x equals 2, relative min of 0 at x equals 0, okay? We also, now this one we have 2 decreasing intervals, 1 increasing interval. Okay, if you look at that. Okay, so that's relative max, that's relative min. We got increasing, we got decreasing. All right, even and odd. Now you've got a little bit more in terms of the definition. Yours says a function f is called an even function if for each x in the domain of f, negative x is also in the domain of f, and this is what goes in that after that and, right there. And f of negative x equals f of x. Okay, so put that at the top. Now here's what's going on for an even function. For an even function, if I plug in 2 and get back 12, if I plug in negative 2, I get back the same answer. If I plug in 4 and get back negative 6, I plug in negative 4, I get back negative 6. You've got to get the same y value for opposite x values. So that is what this means here. F of negative x equals f of x. Okay? gives me the same answer. One of the easiest even functions is f of x equals x squared. We'll answer that second question here in a second. It says something about symmetry, right? All right, let's over here on the right-hand side, let's just graph f of x equals x squared. This is one where -2, -1, 0, 1, and 2 will suffice because we know what it looks like. Plug in -2, you get back 4. -1, 1, 0, 0, 1, 1, 2, 2. All right, what's that symmetric about? Y-axis. Okay. So even functions will be symmetric about the y-axis. Okay, and then f of -x equals f of x for that. So that's an even function for this. An odd function. Okay, odd function. Okay, now you got your definition up there, but if x is in the domain of the function and -x is in the domain of the function, it's an odd function if f of -x equals the opposite of f of x. All right, what does that mean with ordered pairs? Well, with ordered pairs, if I plug in 2 and I get back 8, what would be true? If I plug in -2, what answer would I have to get back? -8. If I plug in 5 and I get back -16, what happens when I plug in -5? I get back +16. Okay. One odd function is x cubed. X cubed. All right, go ahead and plot that on the grid over there. And give me a sketch. So I have, well, if you plug in -2, you can get back -8. That's kind of a little bit below my scale, but I'm going to estimate it down there. -1, -1, 0, 0, 1, 1, and then 2, 8. So when we graph that, we get snakes through the origin. Okay, for that one. All right, what's that symmetric to? Is it symmetric to the y-axis? X-axis? Origin. Okay, it will be symmetric about the origin. Odd functions are symmetric about the origin. All right, now, before you get to the average rate of change, I need you to put something in there. You should have plenty of room. Okay, before you get to the rate of change, is how do we test something for even or odd if we just have the equation? And I want to make sure I go through this. All right, is f of x equals 3x squared plus 7x even, odd, or neither? Now you can like plug in points just to get an idea, but that's not going to be sufficient. You've got to plug in just a general value and a -x. So here's kind of the outline. If f of -x equals f of x, it's even, right? And if I plug in -x and I get back the opposite, it's odd. So essentially what you have to do is you have to, this is a little bit similar to symmetry, but we're just plugging in negative x. Okay, so we want to evaluate f of negative x. And that's going to be 3, and then I got negative x squared plus 7 times negative x. And just simplify that. Now, to be an even function, it's symmetric about the y-axis, so that kind of matches up. When you plug in negative x, you get back the same thing if it is symmetric about the y-axis. All right, that becomes 3x squared minus 7x. All right, is that the exact same as the original? So no, so it's not even. To really test if it's odd, factor out a negative. And if you can factor out a negative and what's in parentheses is the same as your original, I screwed something up, didn't I? That should be a negative there. If what you get in parentheses is the same as the original, then it would be an odd function. Well, is it going to be the same? Because if you factor out a negative, you got to make sure I make that a negative. So it's not. So what is this function? It's not even, it's not odd, so it would be neither. So that doesn't have to be one or the other. Okay, it doesn't have to be one or the other. All right, so that's how you test it. You have to plug in negative x. You get back the original, it's even. You get back the opposite, it's odd. Okay. All right, now on the bottom, average rate of change. Get that formula down on the bottom there. Okay, the average rate of change of f of x as x changes from a to b is defined by f of b minus f of a over b minus a. Okay, and you have to go in that order because if it goes from a to b, you actually got to go f of b minus f of a. So just watch your order. All right, let's flip it over there. I have the picture here because I'm going to show you something. You don't need the picture. Sometimes it helps to just kind of give it an overall understanding, but it's not necessary. So it's find the average rate of change of f of x equals 0.5 x squared as x changes from a equals 2 to b equals 4. All right, so we know we want f of b minus f of a over b minus a. All right, well, what's f of b? You plug in 4 for 0.5, so it becomes 0.5 times 4 squared minus 0.5 times 2 squared over 4 minus 2. All right, go ahead and see what you come up with for that. Good. Riley, what'd you end up with? 3 is final answer because 4 squared is 16, half of that is 8. 2 squared is 4, half of that is 2. 4 minus 2 is 2. 6 divided by 2 is 3. All right, I wanted this picture just to show you what's going on. At the point x equals 2, you get back a y value of 2. At x equals 4, we get a y value of 8. All we're doing is we're taking f of b minus f of a. Well, that is that distance right there, and this is b minus a. What did we just find? On slope. Found the slope of that line. Okay, rise over run. That's all this average rate of change is. You take f of b, which gives you a y value, subtract f of a, which is the other y value, gives you the rise. B minus A gives you the run slope. Okay, that's really all that it means. Okay. All right, last thing we need to cover is called the difference quotient. Whoops, hold on. I think I missed one. Right there. There it is. Need that. All right, for a function f, the difference quotient is f of x plus h minus f of x all divided by h. This is basically one of the building blocks of calculus. We're not worried about how it's using calculus. This is pre-calculus. So we're just worried that you can do the math right. Okay, if you can't do this math right, then it makes things a little bit more difficult later on. All we're worried about is can you substitute that in and can you simplify it? So let's just go through what that means. So compute the difference quotient for f of x equals 2x minus 5. So when it says that, you're going to find f of x plus h minus f of x all over h. That's all it's telling us to do. Like I said, there's a ton of math behind that you really have no idea about yet, and we don't even need to worry about it though. But f of x plus h means you plug in x plus h for x. Okay, and I'm going to put it in brackets to separate it, minus f of x, which is 2x minus 5, just whatever your equation is, over h. So there's your f of x plus h. Here's your f of x. All right, distribute, simplify. That's really all we got to do at this point. Distribute, simplify. Now, distribute here, I get 2 times x plus 2h minus 5. Distribute that negative, you get minus 2x plus 5 over h. All right, so in the end, what's the only thing I'm left with on top? Okay, just the 2h. Okay, everything else is gone. 2h divided by h. It just gives you 2. Okay, those h's will cancel. All right, we got to get through this last one. Copy that down. All right, this one has a little bit more substance to it, I guess. We're still finding the difference quotients, which is f of x plus h minus f of x all over h. Okay. I don't want to go too fast. F of x plus h. Everywhere there's an x, plug in x plus h. So it's going to be 2 times the quantity x plus h squared minus 3 times x plus h plus 1 minus f of x, which is 2x squared, minus 3x plus 1 all over h. All right, what do you have to do where it says x plus h quantity squared? We have to FOIL. You got to FOIL that. Now I'm just going to do this on the side. We did it the other day just because I knew it would come up. But if you have x plus h times x plus h, you're going to end up with x squared plus xh plus xh plus h squared. Which is x squared plus 2xh plus h squared. All right, that's that FOILing part. So now it's going to become equals 2 on the numerator times x squared plus 2xh plus h squared minus 3x minus 3h plus 1 minus 2x squared. Make sure that's a plus 3x and make sure it's a minus 1 all over h. Oh, we're good. Distribute that 2, combine any like terms. And once you get there, just hold on for a second. some things should add up to 0. Some things should add up to 0. All right, now after I distribute that 2, I get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. I know that everything that is after this minus sign should add up to 0, should cancel out, okay? And you'll know that after doing a few, but you get 2x squared and minus 2x squared, that adds up to 0. I got a minus 3x and a plus 3x, and I got a plus 1 and a minus 1. You should also be only left with terms that have an h. So it's now 4xh plus 2h squared minus 3h all over h. You don't have to rearrange them. I know some of you kind of naturally do that, but you don't have to. You can leave them. One thing, though, we need to do, what does everything in the top have? They all have a h. Factor that out, because this should always cancel with the h in the bottom. So I get 4x plus 2h minus 3 all over h. Those cancel. So that's your final answer. 4x plus 2h minus 3. Whew. All right. I knew it'd be tight. There's a lot going on in this mess. A lot going on.